Question number 18. The force on a charged particle due to electric and magnetic fields is given by F equal to 2E plus QV cross B. This is also called Lorentz force. Suppose E is along x-axis and B is along y-axis. In what direction and with what minimum speed V should a positively charged particle be sent so that the net force on it is zero? Here we have F equal to QE plus Q V cross B. Now, for net force to be zero, QE is equal to QE plus Q times V cross B must be zero. That is, E equals V cross B with negative sign, or V cross B is equal to minus E. So since E is along positive x-axis, it means V cross B must be equal to, we can write in terms of component. So we write just E in magnitude times minus I cap, because E is along I cap. This minus sign is written here. Now, this can be written as, suppose, in magnitude V times a vector n cap, and for B, we write magnitude B, and then since B is given along y-axis, so we can write j cap equal to E times minus I cap. So if we use a rule of cross product, suppose this is I cap, this is j cap, this is k cap. So if we move in this right direction, j cross k, so we will get I cap, but here we have to get minus I cap. It means it should be k cross j. BV k cross j. That will give E times minus I cap. It means this V velocity is along positive z-axis. So V is along positive z-axis. Now, in magnitude, VB sine theta equal to E. So V equal to E divided by B sine theta. For V to be maximum, theta should be. Here question says, what is minimum speed? So for V to be minimum, theta should be maximum, and that value is sine 90 degree, that is 1. So theta is 90 degree, from where we get V equal to E upon. So that's our answer. Give an example for which vector A dot vector B equal to vector A dot vector C, but vector A does not equal to vector C. So it is very simple. Suppose we take vector B equal to I plus J. Vector A equal to minus I plus J, and vector C equal to I minus J. Now, let's find out A dot B. If we find A dot B, so here A dot B will give minus I plus J times I plus J. 1 minus 1, that is 0. Similarly, if we find A dot C. So A is RE plus J dot C is RE minus J, that is 1 minus 1, which is also below. Here it is first minus 1, then plus 1, but both are same thing. So it will give 0. This also gives 0. So we have proved that A dot B equal to A dot C. And clearly, A and C both are different vectors. A is minus I plus J and C is I minus J. If we want to locate these vectors, so here B will be like this. This point, this is I plus J, 1, 1. This is 1, this is 1. Another vector is minus I plus J. It means it will be like this here. And that's minus 1 plus 1. So this is minus I plus J. And third vector I minus J will be like this. Here, this is I minus J. This positive 1, then downward 1. So this becomes I minus J. This is vector B, this is vector A, and this is vector C. Clearly, they are directed in different directions. Now, let's see this question. Though this question needs a graph paper to get correct answer, yet I will explain it later on. You can do it by using graph paper. So here the values are plotted for x equal to 1, y is 2. Similarly, for 2, y is 8. For 4, y is 32, etc. It is not properly drawn. It is not drawn to the scale. You have to draw it on graph paper, then you will get correct answer. But if we find these slopes and we evaluate the slope by this, we will get same answer. So here, I at x equal to 2. If we find dy by dx, so we have to put this value and then this value, and that will be equal to 4 into 2, equal to 8. So similarly, for I at x equal to 4, if we find dy by dx, means tan theta from here, so it is difficult on this. So I'm directly writing the result. So tan theta will be 4 into 4, that will be 16. Similarly, for x equal to 6, for x equal to 8, tan theta or dy by dx can be found. Now, let's see question number 21. A curve is represented by y equal to sin x. If you remember, graph of sin x is like this. This is y equal to sin x. Here, y changes from this value is, this is x-axis. So suppose this value is pi by 3. So x changes from pi by 3 to pi by 3 plus pi by 100. Suppose this value. Pi by 3 plus pi by 100. So we have to find out corresponding change in y. So here we are going to apply very simple technique. So y equal to sin x, if we find dy by dx, that will be cos x, or dy equal to cos x dx. We put the values here. We have to find out dy. So here x means first value, x equal to pi by 3, and dx means pi by 3 plus pi by 100 minus pi by 3, that is pi by 100. So we put this value here, pi by 100, and x here. So this becomes cos pi by 3 times pi by 100. Cos pi by 3 is half, 0.5, and pi by 100, pi is 3.14. So this will become 0.0314. So if we evaluate it, it will become 0.0157. And that is our answer. There is another method also, but this is better method. Question number 22nd. The electric current in a charging RC circuit is given by I equal to I0 e to the power minus t upon RC, where I0, R, and C are constants and t is time. Find the rate of change of current at t equal to 0, t equal to RC, t equal to 10 RC. Rate of change of current means we have to differentiate it di by dt. So we will get minus I0 upon RC times e to the power minus t upon RC. When t equal to 0, this term will become 1. So di by dt at t equal to 0 will be minus I0 divided by RC. Now, second case, di by dt when t equal to RC. So here it will become minus I0 upon RC e to the power. RC upon RC is minus 1. And next case is when t equal to 10 RC, di by dt, when t equal to 10 RC, it will be equal to minus I0 upon RC times e to the power minus 10. And that is our answer. Let's go to next question. The electric current in a discharging RC circuit is given by I equal to I0 e to the power minus t upon RC, where I0, R, and C are constant parameters and t is time. We are given I0 equal to 2 ampere, R equal to 6 into 10 power 5 ohms, C equal to 0.5 microfarad. Find current at t equal to 0.3 second and the rate of change of current at t equal to 0.3 second. So let's find out the current by putting the value. I equal to I0 is given as 2 into e to the power minus t, t is 0.3 divided by RC. R is 6 into 10 to the power 5 into C is 0.5 into 10 to the power minus 6. So we will get 2 into e to the power minus 0.3 upon 0.3. So it will become 2 into e to the power minus 1, that is 2 upon e ampere. Now, second part, we have to find out a rate of change of current at t equal to 0.3 second. So we find di by dt equal to, we differentiate it. So I0 upon RC times e to the power minus t upon RC. Now t equal to 0.3 second. So we will get I0 is given to, so minus 2 upon RC we have evaluated as 0.3 and e to the power here t equal to 0.3. So this will become minus 1. That will be equal to minus 20 upon 3e ampere per second because di by dt. And one part is not written. We have to find out the current when t becomes 0.31 seconds. So let's evaluate it. So I equal to 2 here, 2 times e to the power minus 0.31 and RC we have evaluated as 0.30 or 0.3. So this can be written as 2 times e to the power minus 31 upon 30. So this is our answer, but in our textbook, answer is different. So That is next step of this. So let's try to get that answer. So we can write it, negative power we can take in denominator. So this will become 31 upon 30, which can be written as 2 e to the power 1 plus 1 by 30. That is 2 upon e times e to the power 1 by 30. Now, if we evaluate e to the power 1 upon 30, so that comes out to be 0.9667. And we know that 3 upon 2.9 is also 7. 1 upon 0. Here it is in denominator, 1 upon 0.9667. So in place of e to the power 1 by 30, we can write 2 upon e, and here we write this 3 divided by 2.9. So this 2.9 will go in numerator. So this will make 2 as 2, this 5.8 divided by this will become 3e, and then ampere, because we wanted to get current. So this is our answer. Thank you for watching.